Welcome back. We're going to continue looking at steam table examples. Now, if in that last video you weren't really sure exactly how everything was working, if you've noticed, I provided with you guys a flow chart, and I called it the steam table flow chart. So this should help you kind of figure things out. And after I go over this, we'll go over some examples, and then we'll use the flow chart so you can see kind of how it works. What it's got here is it's got 5 different little flow charts. Okay, and the top block is going to represent the information you are given in your problem. So for example, in this one, we were given a pressure and a temperature. Now, as you go through the flow chart, it kind of walks you through the steps to help you figure out which table you should be using. So in this case, if I was given pressure and temperature, I'm going to use the pressure to find my saturated temperature, and then using that saturated temperature, I'm going to compare my given temperature to that Tsat. So if my temperature is less than the saturated temperature, I know I've got compressed liquid. If I have a temperature greater than the saturated temperature, I've got superheated vapor. Right? So that's kind of how the table is set up. And then as you go across, you'll see you have different inputs. So here you've got a pressure or a temperature and internal energy. So it just walks you through the steps on what to look for and then how to know which table to choose. So hopefully you'll find it helpful. The students in my class typically like this flow chart. They always want to have it on the tests. So hopefully you'll find it helpful as well. Okay, so let's look at a few more examples. These I don't have typed out, we're just going to write them out, and then we'll look at the flow chart and see how it goes together. So this first one, let's just have a pressure that's equal to 30 bar, and we'll have a temperature that is 320 degrees Celsius. We're going to always start out at our table. Okay, so let's look at the pressure table, and by table I mean the liquid vapor table. Let's start out with the pressure table. So that's table A3. So I've got a pressure of 30. So I'm going to look on here, find 30. My temperature is 233.9. This is my saturation temperature right here. Right? Is this, remember, is the temperature where vaporization starts. So that's the saturation temperature. So keep that number in mind. And let's go ahead and let's draw our vapor dome. So now let's put on here what we found in the table. So at 30 bar, our saturation temperature was 233.9. Now our temperature is 320. So this means we're above here. We're up here somewhere. Okay. So now what you're basically going to do is intersect this line. So you want to intersect where temperature is 320 and where pressure is 30 bar. So this tells you we need superheated vapor. Okay. So you could go and then you could find whatever property you need in the superheated vapor table. Okay. So if we use this flow chart I gave you, what we're going to do, let's look at this first one. We've got pressure and temperature. We're going to use pressure to get our saturation temperature. We did. Saturation temperature was 233.9. Our temperature is 320. So our temperature is greater than the saturation temperature. So we've got superheated vapor. Okay. So this flow chart here will help you not have to draw that diagram if you don't want to draw it. Okay. So now we've got that. Let me get another one here. And let's see. For this one, let's have a pressure of 30 bar and a temperature of 320 degrees Celsius. Okay. Now what we're going to do here is we're going to work this in a different way. So if you notice, this is the same thing we had before. Okay, but this is just showing you how to use a different kind of table for this one. So in this case, let's look at the temperature table. So let's take T1, all right, which is 320, and let's find the pressure, so the saturation pressure. So this is going to be table A2 if you're using, whoops, sorry about that, if you're using the Moran book. And at 320, we have a pressure of 112.7. So this is our saturation pressure. So 112.7. Let's write that down like that. Now, in this case, since we're looking up the temperature table, let's do a PV diagram. So we haven't really looked at these yet, but you do see them occasionally. So this is just switching it out where we have specific volume and pressure now. And then the lines that we're going to draw on our vapor dome are going to be isotherms, or constant temperature. So now with this, if we are at a temperature of 320, our line that we're going to have is going to look like that. All right, so it kind of switches the shape it has when you're doing the PV diagram. So this is going to be a line of constant temperature, or an isotherm, and this would be the 320 degrees Celsius. All right, now this saturation pressure for right here, that's going to be where we have vaporization. That's going to be the 112.7 bar. So that's your pressure for this line right here. We are at 30 bar. So we're down here somewhere. All right. What we need to do is find the intersection of the temperature at 320 and the pressure at 30 bar. So essentially you're just going to draw this line over here to where it intersects. We are to the right of the vapor dome, so we're going to have superheated vapor. All right, so you would use your superheated vapor table to find your specific volume or whatever it is you're looking for. All right, so we did the same problem two different ways. So I just wanted to show you this way because sometimes that will appear in books and we hadn't really talked about it yet. Now, if you look in the table or the flowchart that I gave you, that would be this one. We had pressure, temperature. We used temperature to get the saturation pressure, and then you just compare the values. So our pressure was 30. That's less than the saturation pressure, so we have superheated vapor. All right. And let's do a couple more of these. Let's do one where we change it up a little bit. So this one, let's have a pressure, let's call it P2, 25 bar, and now our temperature will be 100. What we're going to do, we're going to start out with the liquid vapor table. I'm going to use the pressure table, and I'm going to find the saturation temperature. All right, so we got 25 bar. So if you look right here, saturation temperature is 224. All right, so we get 224 degrees Celsius. And now if we want to draw a diagram here, have it look like that, and put our dome. So at a pressure of 25 bar, this temperature right here where we have vaporization is going to be 224 degrees Celsius. We are at a temperature of 100, so we're going to be down in here somewhere. Okay. So we want to have the intersection of the temperature we're at, so 100, and this pressure line. So if we extend our pressure line down, all you need to do is find where they intersect. So it's right here. This would be compressed liquid because it is to the left of that vapor dome. Okay, so now we've got that. And again, if you look in the flow chart, you'll see that that's what you'll end up with. Okay, so here we got our saturation temperature. It was 224, so you just make the comparison. Ours is 100, so ours is less than the saturation temperature. We go to compressed liquid. And let's see. This last one. For this one, let's say P3 is 5 bar. We've got a temperature of 151.9. Let's go to the pressure table again, find the saturation temperature, and see what we get. So 5 bar, we get 151.9 for the saturation temperature. Okay. Now, notice these two are the same. So let's draw this picture. Put our ISO bar. So this is for 5 bar. And our temperature here is 151.9. Right? Same temperature that we stated that we had. Okay. So this means that we're going to need quality. We need something here to find the exact value, but we know that we're in this range somewhere. So we have a liquid vapor mixture. Okay, but we would need another property or something to help us figure out exactly where we are in here. So typically you'd want quality. Okay, but we know we have liquid vapor. Okay, because our pressure and the saturation temperature match up. Okay, so let's stop there on those. Hopefully that gave you enough examples, and the flowchart will help you kind of figure your way around the tables. And we'll have one more video on an example. This next example is going to use quality, so we'll cover that topic a little bit more in the next video. You guys have a great day. See ya.